Hello everyone, today let's take a look at quantipus number 48, another combinatorics question where we're going to use stars and bars. In this question we have a bakery selling 6 kinds of donuts and a customer wants to buy exactly 15 donuts, but they insist on getting at least one of each kind but no more than 4 of any one kind. So in how many ways can they place their order? So if you can imagine, I have my 6 types of donuts represented by these underlines and I need to distribute 15 donuts among them and count the number of ways to do so. So for instance, this could be one way to distribute my 15 donuts, right? I give 4 to type 1, 4 to type 2, 1 to type 3, 1 to type 4, 4 to type 5, and 1 to type 6. And as long as they add up to 15 and they satisfy this constraint right here, then we're good. So what we're trying to solve is the number of solutions to this equation right here, where each xi represents the number of donuts which we distribute to the type in the subscript, right? And obviously the number of donuts we allocate has to be an integer and it has to be between 1 and 4 because of this constraint. So we solve this using stars and bars, we know, and since we have a lower bound on it, we're just going to distribute 1 donut to every single type of donut like I'm doing here. So once we've done that, we've already distributed 6 donuts out of 15, so I need to subtract 6 from 15 and I get 9. Now I need to calculate the number of ways to distribute these remaining 9 donuts to 6 categories, subject to the constraint that no donut can have more than 4. So what I'm going to do is I'm going to use stars and bars to calculate the number of ways to distribute these 9 donuts as if there was no constraint, and then I'm going to subtract off the cases where one of these xi's is exceeding our constraint. So we know how to do stars and bars, right? It's going to take 5 of these lines to divide into 6 groups, as we know, and we have 9 donuts. So all I need to do is count the number of ways to choose 5 of these 14 places to put my bars, and then all I'm going to do is fill in the donuts in the remaining spots, and each one of these is going to give me a unique way of dividing up the donuts. So we know the number of ways to do so is 14 choose 5. Now all that's left for me to do is take this number and subtract off all the invalid solutions that violate our upper bound. For instance, this one allocates 7 donuts to one type, and we know that's not possible because our constraint says maximum 4. So now to do this, let's just come down here first and define some variables. So let's let A1 be the set of solutions where x1 is greater than 4, A2 is the set of solutions where x2 is greater than 4, and so on down to A6. And we know that any solution which violates at least one of these is going to be invalid, right? So we need to take the union of all of these invalid solutions and subtract them from here. And we're just going to calculate the magnitude of this using inclusion-exclusion. So first of all, let's find the magnitude of A1 here. So if we come back and we look at our 6 donuts, I'll draw them out again. Then we need to allocate 5 to A1, right? The set of solutions where x1 is greater than 4, so we're going to give it 5. Every other donut type has to have 1, so let's do it like this. Now remember, we had 15 donuts originally. We need to subtract the 10 that we allocated here, so we get 5 donuts left to distribute to 6 donut types. And the way we do this is just basic stars and bars, right? I have 5 donuts plus 5 bars to divide into 6 categories, so that's just going to be 10, and I need to choose 5 of them for the actual bars to go. And we know that the magnitude of A2 will also be the same thing because every donut type has the same constraints, right? It's just going to be the same problem, and so on for A3, A4, A5, and A6. So therefore, the total number of invalid solutions will be 6 times 10 choose 5, but wait a minute, did we overcount anything? And it turns out that I actually am overcounting because let's say in this situation, when I had my 5 donuts left to distribute here, if I distributed all 5, for instance, to donut type number 2, so I had 6 here actually, well then the constraint on x2 would have been violated because this would have been greater than 4, so I will end up overcounting. So this just means when I was calculating the violations for A1, I was overcounting those that included the violations for A2. So how do I fix this? Well, we know that by inclusion-exclusion, I have to subtract off the magnitude of the intersection of all of our sets. So that would be A1 intersection A2 dot dot dot. So what is the actual magnitude of this intersection? Well, let's come back here and let's just distribute so that both of our bounds are violated. So 5 to type 1, 5 to type 2, and then 1 to all the others. Now I can add all these up. I had 15 to start with, but I used 14, so I only have 1 donut left to distribute to the 6 remaining spots. So how many ways can I distribute 1 donut to 6 spots? Well, obviously it's just going to be 6 ways. And we also know that for every single one of these pairwise intersections, right, like for instance A1 and A3, if I calculate it like this, it's going to give me the exact same number. It's going to be 6 every time. So what's the total number of pairwise intersectors that I can get from a group of 6? Well, it's just going to be 6 choose 2, right? So essentially the magnitude by which I overcounted is just going to be 6 times 6 choose 2. And I just need to subtract this from this to give me the total number of invalid solutions. Now for the inclusion-exclusion, the reason we didn't calculate the triple intersections and the quadruple intersections and etc. is just because it's not possible, right? Because I only have 15 donuts, so there's no way that I could have 3 different variables that exceed 4 donuts. 10 choose 5 is equal to 252, so 6 times 10 choose 5 is going to be equal to 1512 after some calculation. We also know 6 choose 2 is 15, so times 6, this is going to be 90, so 1512 minus 90, that's going to equal 1422 invalid solutions. So now all that's left for us to do is just take the total and subtract off the number of invalid, which is 1422, and this will give us our final answer. So on a calculator, I got 14 choose 5 as 2002. So when I subtract 1422, that's going to end up equaling 580. And this is going to be our final answer. There are 580 ways to distribute 15 donuts to 6 different types, subject to the constraints that each type can have between 1 and 4 donuts allocated to it.